here's another example of solving a circuit using superposition. A slightly more complicated circuit this time, because this time we have a dependent source. And when using superposition, we have to remember that when we're shutting down our sources, we cannot shut down the dependent source. So, to start off solving this circuit, I'm first going to copy this circuit so that we can modify this new circuit. So to start off, we're going to start out with the voltage source right here, which means that what we're going to do is we are going to go to this current source and turn it into a wire, or an open, turning into an open, because we have to remember that for current sources, we make them open, and for voltage, we turn them into a wire. So now, what we're going to do is we could have the option of doing mesh analysis or node analysis. And since we're trying to find the voltage across this resistor, I think it'd be best to do node analysis, because we'll have one node right here and another node right here. If we were to do mesh analysis, we would have 3 loops, or we would have two. We could do 2 loops, but since we want the voltage, we'll do node analysis. So to start solving this problem, we'll start with solving for node A. So we'll start out with A minus 80 divided by the 6 ohm resistor right here, plus A minus B over this 2 right here, and then plus A divided by 8. Move this over so we can draw some more. And then for this dependent source, we're going to do equals 3ix. And we want to remember, I'm doing equals, or we're putting the 3ix on the other side, because with node analysis, we are doing out, or with node analysis, it's out equals in. Current out equals current in. And everything on this side, right here, is all current going out. And since this is a current dependent source, and it shows that it's going into A, we will put it on the other side of the equal sign. Okay, so now we will just find a common denominator for all of these. So if we just pull out a calculator, find a common denominator for 6 and 8, and we see that 24 should work for all of these. So we'll just multiply this top and bottom, or this top by 4, so we'll get 4a minus 320 plus, multiply this by 12, 12a minus 12b plus 3a equals, and then we just multiply this right side by 24. 24 times 3 is 72, 72 ix. And now we just combine everything, so we'll end up with adding all these 12s, we get 19a minus 12b and then we'll move this ix because this is a variable that we are unsure of, so we want all of our variables on the left side, plus, or be minus 72 ix equals 320, because we're moving this 320 to the other side. So that's A done, and then we'll do B. So for B, we'll just start out with B minus A over 2 plus B over 4. And then, so now we have these current dependent source again, and it's going out of B. So we will add it to the left side of the equal sign. So plus 3x equals 0. Okay, and now we can simplify all of this. So we'll just multiply this right here by 2 to get a common denominator of 4. So it'll end up being 2b minus 2a plus b, and then we multiply this 3 by 4 because we have we're practically multiplying everything by 4 here. So we'll multiply this 3 by 4 to get plus 12ix equals 0. So here are our two equations that we are going to use to put into our matrix. So I'll just write out the matrix that I'll be using right here. 19, negative 12, negative 72. Oh wait, there's one more step I forgot. Okay, so we have to get an equation for this ix. And looking at our circuit right here, we can see that the equation for ix is actually going to be a minus 80, or it'll be 80 minus a over 6 will equal ix, because we're doing voltage right here, voltage divided by resistance, which is the formula for current. And we want to go from high to, the current is going to the right here, and current goes from high to low. So we put it as such, 80 minus a divided by 6. And then to make this a equation that we can put into our matrix, we will make it equal to 0, or get all the variables the unknown variables on the left side. So we'll just multiply the right by 6, or both sides by 6. So we'll get 80 minus a equals 6ix. And then we will subtract this, or we'll add the a to the right side so that we get all of our unknowns on one side. So we'll end up with 6ix plus a equals 80. So that's the equation for our ix. And now we can plug in, or we can create our matrix. So our matrix will end up being 19, negative 12, negative 72, 320, and we'll have, didn't simplify this one, this will end up being 2a, 3b plus 3b plus 12ix equals 0. So that's the simplified version of that one. Forgot to do that. So end up with this one will be negative 2, 3, 12, 0. And then we'll add this equation right here for our ix. And remember to line everything up. So this will be 1, 0, 6, 80. And now you can plug that into your calculator and get the reduced row echelon form of it. And when doing that in your calculator, you end up with A is equal to 42.67 volts. B is equal to 3.56. And for our IX, we get 6.22. Now, these aren't our answers. If you remember that this is only the answer for the voltage source. Only for the I even say 80 volt. Yep, only for the 80 volt voltage source. So now we have to do it for the current source. So I'll paste the circuit again. And now we'll move on to the current source. So when choosing this one, we will turn this voltage source into a wire. Okay, so to solve this circuit, we could do mesh analysis, but that would leave us with 4 equations. But if we just see here, we have A and B, which is just 2 nodes. So we'll go with node analysis again. And to start off, we'll start out with A right here. So that will lead us with A. Start out with A minus, actually we'll start out down here. Divided by 4, because we're doing right here. Remember, this node right here, this is all one big node, which is all 0. So technically, right here, we're doing A minus 0, but I've just cut that off. So continue, A minus B divided by 2, and we'll see this current, this dependent source is current is going out, so it'll be on the left side, plus 3ix, and then we'll see this current source right here is going in, so we will make it put it on the right side, because remember, out equals in for node analysis. Put it on the right side, and it's equal to 6. Now we'll simplify, multiply everything by 4, and so we'll have A plus 2A minus 2B plus 12ix equals, multiply this by 4, 24. And then add all like terms, we'll end up with 3A minus 2B plus 12ix is equal to 24. So there's our finished equation for that, for A. Now we'll move on to B. So let's start off, we'll have B over 6, starting off right here, plus B over 8, plus B minus A over 2, plus, and now since this current, this dependent source right here is going into B, it'll be on the right. So equals 3ix. Okay, now we'll just continue down here, simplifying this circuit. So we'll multiply everything by 24. Yep. So we'll end up with 4b plus 3b plus 12b minus 12a equals 24 times 3, 72ix. So now we'll put all of our unknown variables on the left side, and then also add all like terms at the same time. So right here we have negative 12a, then add up all our b's, and we get 19 plus 19b equals, or no, we want to move this ix over, so we need negative 72ix equals 0. And there is our final equation for B. Oops, for B. And now we also need an equation for for our ix right here. And then we just see that it's simply just B, our equation for Ix, is just equal to B over 6. Because our 0 node is on the other side of this 6 ohm resistor. So then we'll put all of our unknowns on the right side. So we can do this by we'll start by just multiplying this 6 over to the Ix. So we'll get 6 Ix equals B, and then subtract over the Ix. Or we can subtract over this B, doesn't matter. So end up with 0 equals, we'll do it the other way. 6Ix minus B equals 0. And then we can now create our matrix that we're going to use for node analysis. So start off with this top, our A node, 3, -2, 12, 24, and then our B node right here, -12, 19, -72, 0, and then our Ix, which will be 0, -1, 6, 0. So there we are. And then we'll put that in our calculator, use reduced row echelon form, and we'll get something like, we'll get A is equal to 8, B is equal to 13.71, and our Ix is equal to 2.29 when rounding. Which we're not really looking for our Ix in this problem, we're specifically looking for, if we go back to our circuit, and it looks like I swapped variables, so this should be B, and this should be A, just to make things more helpful. So this is B, and this is A. Because now what we're going to do is we have to take these variables right here, and we have to add them to the variables we just found to find the correct voltage across our resistor, our 4 ohm resistor right here from node B. So what we can do is we can simply just add all of our B's together. Add up all of our B's. Okay, so if you haven't caught my mistake already, this B right here should be a plus because it's going from, remember we want to go from high to low, and this current is going from 0 to 6, so it would be 0 minus B. So when we would bring it over, it would be plus B. And when we do plus B, we get some slightly different answers where B is 16.53 and A is 6.4. And then this is -1.07 when rounding. So now that we have our B from the voltage source, and then this is our B from the current source, 16.53, if we just add these together, we get 20.1 volts. And that is our answer for this circuit.